ladies and gentlemen, we're going to take a look at operations with polynomials. So we've worked with monomials in how to manipulate them, how to divide monomials, how to multiply monomials. That was our 6-1 lessons. Now we start talking about polynomials, taking a look at more than one term in our expression, thus polynomials. And so now we're going to take a look at how do we operate with those. So we're going to start with the first operations, addition and subtraction. And addition and subtraction means you're going to combine like terms, but like terms now needs to take on a little bit of a more broad definition. And so what we have to have, it has to be the same variable and the same exponent. So I have to have the same degree. So quartics combined with quartics, cubics with cubics. And so we should be familiar with that from chapter 5 in our quadratic unit. But what I'm simply going to do is combine those like terms. We're going to add in the first example. So I look through for the largest exponent, and these are nice problems because they're in standard form. So I've got 7x to the 4th plus 2x to the 4th is 9x to the 4th. I then have to look for any x to the 3rd. So notice I'm not using this negative 3x squared. I'm using this plus 5x to the 3rd. I want my answer written in standard form. Then I look for x squared, so there's only one. I look for a linear term, and there are no linear terms, and so then I'm left with my constants. 6 minus 6, which is 0, and so here's our new polynomial. When we take a look at subtraction, ladies and gentlemen, I want you to think of this as though you're distributing a -1 first. You're adding the opposite. So you're going to change all of the signs in here. So really you're adding negative 3x to the 4th, you're subtracting 5x to the 3rd, and you're adding 7x. You're doing the opposite. And so now that I've done that, and I've changed this to an addition problem, these are now the same exact problem. So I can just combine like terms. Once again, scan for the largest exponent. The largest exponent is negative 3x to the 4th. After x to the 4th, we become x to the 3rd, so we have 9 and negative 5 is a positive 4x to the 3rd. After that, we have x squared, and there aren't any. Then we have our linear terms, so we have plus 9x, because 2 plus 7. And then after our linear terms, we should have our constants, and so there's just the 1, and it's minus 4. Notice, because we're to think of it as distributing that negative, we only affect the polynomial after subtraction. Now we're going to move on to multiplication, and you guys should be pretty much experts at this. If it's a monomial, you're simply going to distribute to every term. Use your exponent rules, so we're going to add those up. We multiply coefficients, 15, and then we add our exponents. 2x's and 3x's is 5x's. We distribute -6, and then 2x's and 2x's is 4x's. We then have plus 12x to the 3rd and minus 24 x squared. When it's a monomial, more than likely your final answer will already be in standard form, and you're not going to have any like terms to combine. A binomial times a binomial, you guys know to use FOIL. It's just the distribution that we've always done. And then what you have to remember to do is combine like terms at the end. So we're going to have 12x squared from 6x times 2x, and then 6x times 7 is 42x. Now realizing what you're seeing tonight, we could have x to the 3rd times an x squared. We have a lot more options now that we're out of our quadratic union. I then need to distribute the -5. I have negative 10x and minus 35. So this problem here should look very familiar. You've already done that for me in chapter 5. Combine your like terms, leave your largest exponent first, so you're writing it in standard form, 12x squared. Your like terms end up here in the middle. We have plus 32x, and then you have a constant at the end, minus 35. Now we're going to take a look at if we have to do a binomial times a trinomial. It's the same thing, we just distribute to every term, but this time we're going to distribute 3 times with that x. So this is 3x to the 3rd minus 4x squared plus x. It just increases the degree on each term. So a quadratic became a cubic. X became x squared. Now we distribute the 5 to everything, and we get plus 15x squared minus 20x and plus 5. Now our like terms aren't going to be right next to each other, so we are going to have to do a little bit of looking. But our largest exponent is x to the third. I then have 2x squareds, which give me 11x squared. I have x and negative 20, which is negative 19x. And then plus 5 at the end. Now for the last one, you can multiply any of the two polynomials together and then use that new problem to make one like the previous question. So we're going to make it look like binomial times a trinomial. So what I want to keep in mind here, guys, is I'm going to take this 3x minus 2 and save it for the front. It's going to look like what we had there. Now I'm going to distribute here. I get 4x squared minus 28x plus x and then minus 7. And now what we can do is simply go into that. Even though I didn't combine like terms, guys, I'm okay. Your answer is going to work out. It's just saving me an extra line of work or an extra step, I would say. I'm going to distribute here. I get 12x to the third. This is going to be a negative 84x squared. This is going to be a 3x squared. And then I'm going to have a negative 21x. I might have to move this over to make sure it all fits there. I then have to distribute with the negative 2, so that's a minus 8x squared, a positive 56x, a negative 2x, and then a positive 14. And now what I'm going to do is look for all of my like terms. I'm going to start with this x to the third, so I have 12x to the third. More than likely, your largest exponent, your largest degree is going to be right there in the front. I then need to look for all of my x squareds and combine those together. So this is going to give me a negative 81. And then a negative 8 is going to give me negative 89. So minus 89x squared. I've got 3 x's here to combine together. So negative 21 and 56 is 35. And then 35 minus 2 is 33x. And then we have plus 14. And so if we look, we go in descending order. The only thing I really see as being our most common mistake here is just mental math there at the end when you're combining things together. So please watch out for that. I did mine without a calculator, but I would keep one nearby. All right, we'll see you guys tomorrow with any questions.